I guess we are live. Hello, everyone. Yeah. Oh, great. Yeah, so we will discuss the first five problems of today's div 2, today's CodeChef div 2. The reselling items sets different by case, some one and A to B easy and hard version. Okay, so let's start with the first problem. Also, let me check if my will sorting. Great. So let's start this session. Starting with the first problem. The problem says uh, Keith is trying to buy some items from a store and then resell them elsewhere to make profit. For the ith item, Chef knows that he can sell it for AI coins. Okay. The store has an ongoing offer. The first K items that Chef buys will be offered at a discount of 5 coins each. The remaining items will be offered at 10 coins each. Okay. Chef can choose to buy any number of items and in any order that he desires. What is the maximum profit chef can make? Great. So let's first of all understand the problem. Yeah, question one. So we have n items, and what we can do is we can buy first k items for 5 coins, and then next n minus k items for 10 coins. Right? We can buy first k items for 5 coins, and then next n minus k items for 10 coins. So what we need to do is we need to maximize our profit. Also, we can select any item from this set of n items and we can buy that particular item, right, for the given amount. Now we need to maximize the profit. So let's first of all, it is very everyone can see that we need to first of all sort the array so that we get the prices in a sorted order. Uh, since the sequence is not matter does not matter, and we can select any of the items. So first of all, we will sort this array, right? After sorting the array, let's say this array becomes something like B1, B2, B3, and Bn, right? And also, this is sorted in. Let's say this is sorted in decreasing order of the price, right? We have sorted the array B in array A in decreasing order, and it looks something like this one. Okay. So of course, first of all, we will buy the item that we can sell for the maximum value. That's why we are sorting it in the decreasing. Now, what we can do is uh, we can buy the first k items here only for 5 coins, and the next n minus k items for 10 coins greedily, right? The first k items we'll buy for 5 coins that we can sell for the maximum value. And the next 10 minus k items we will buy for 10 points, right? So you can simply make an array for this of first k values to be 5 and the next n minus k values to be 10, right? And then we can simply check that if b1 is greater than 5, then only we will buy b1. If B1 is greater than 5, then only we will buy B1. And we'll add B1 minus 5 to our answer. Similarly, we will check for B2 as well, for B3, and so on. And in the first occurrence, where any BI minus AI, let's say this is A, the first occurrence where BI minus AI is less than or equal to 0, we will not buy any item after that, since the profit is less than equal to 0 after that, right? And we need to maximize our profit. So that was the very simple logic of the first question. So implementation is this. It looks like this. Just a second. So we will first of all input the our array, and for the this is our selling price array, and this is the cost price array, right? So for first key items, we will mention it as 5, and for the next 10 minus key items, the cost will be 10. We will sort both the arrays. A is already sorted. It is not required to sort the array. I just did. And for all of the items in B, we will simply check if bi minus a of n minus I minus 1, or you can say something like that. What we are doing exactly here? This is sorted in decreasing order. This is sorted in increasing order. If we sort both the arrays in increasing order, let's say if B was also in increasing order, then what we are doing is we are checking the first element of A and the last element of B. If it was in increasing order, but if it is in decreasing order, so that's why it looks like the simultaneous elements here, right? So yeah, we will check. We will just add the profit made by that particular element, that particular element to our answer, and I think we output the answers. Okay, so just like no one is. Let's do the second question. Let's difference by A. So for a permutation P and an integer K, we define f of P comma K as the set S formed by the following process. Initially, let S be an empty set. So for each I from 1 to n, we will check if there exists sets in S such that mod of S minus Pi is less than equal to K, and append Pi to S. And also, if and only if there does not exist such X, then only we will append it to S. So that is how we are forming S for a particular permutation, right? Now, you are given a set S of elements represented by a binary array B size n. Here, X belongs to S if and only if Bx is equals to 1, right? So what we are given the set S here, okay? And we need to find out if we can form a permutation P with the given value K such that we will get the given S, right? So first of all, let's again understand the problem. Yeah. Question two. So what first of all, what process is happening here? Uh, let's say you have a set right now. This is your set S, right? Initially, it will be empty. So, and you also have a permutation P. Okay, say P1, P2, Pi with in between, right? So, what you need to do is for every I from 1 to n, we are checking that for every Pi, if Pi minus K let me check 1 second. Yeah, if pi minus x, you say. If mod of pi minus x is less than equal to k, then we will not add pi to the set. And if pi minus x is greater than k, then insert pi to s. Okay. So yeah. Now what does this particular thing signify? Suppose this is pi on a number line. Like this is pi. Uh, let's say this is pi minus k, and this is pi plus k. So if there is any value within this range in the set, then we cannot add pi, right? Otherwise, we can add pi. If there is any value within this range in the set, then we cannot add pi. So now again, you are given the set S. Okay. Also, one thing that we need to note that when we will form the permutation, you can see that first of all you will add P1 to the set initially. S set is empty, so there is no value in set. Then we will insert P2. If we can insert P2 in the set, we will. Otherwise, we won't. Through the method that they have described in the question. We will do this for every PI up to n. So we cannot skip any of the PIs, right? Why do we need to note that? We will find out later. Okay. So let's say we were given the set S, right, in the question. So you are given the set S. Let's say the elements that are present in the set S are S1, S2, S3, S4. This is in increasing order, let's say. We are given the set S in the form of Boolean, right? In the boolean of an element. So whatever elements are marked as one are present in the set. So let's say we have made a set of all the elements that were marked to be present in the set. Uh, Now the first thing that we need to notice, as we can see here, uh, if we need to add a pi, right? If we need to add a pi, there should be no element in the range pi minus k to pi equals k in the set, right? Initially. So let's take this S2 and S3, or you can say any SI and SI plus 1. Note that this is in ascending order, okay? So for any SI and SI plus 1, if the difference between SI and SI plus 1, or you can say SI plus 1 minus SI, if SI plus 1 minus SI is less than equal to K, then we cannot form this set. Why? Let's say so you are inserting SI plus 1 and SI both in the set, right? Let's say if you inserted SI in the set earlier, so SI is already in the set, and then SI plus 1 came. So when SI plus 1 will come, and you will see this particular range, right? This is the number line, right? So you will see this particular range of SI plus 1 plus K and SI plus 1 minus K. Element of this range is 2K, right? So you will see this range. You will see this range and see if there exists any element in the set within this range. So if Si plus 1 minus Si is less than equal to K and Si was already present in the set, then we can see that we cannot insert Si plus 1, right? But Si plus 1 is there in the set. So the set cannot be made. Now, if someone of you might argue that we will insert Si plus 1, we will insert both of these elements in any other order. So what other order is possible? Let's say we have inserted Si first, No, we did it right. Sorry. Let's say we have inserted si plus 1 first. Okay. We have inserted si plus 1 first. And now we need to insert si in the set. Right. Again, you will see that si will come somewhere around here, right? In this range. Si minus si plus 1 minus si is less than equal to k. So for the si, okay, let me mark this as si. So si plus 1 will be somewhere around here. So we will see that an element that is si plus 1 that is in this range of 2k elements is already in the set. So we cannot insert si. So by we can clearly see that if anywhere, if the difference between two elements is less than or equal to k, and if we sort it in increasing order, then the difference between any two consecutive elements is less than equal to k, then we cannot insert both of these elements in the set. But if the question says that these two elements exist in the set, then we cannot form a permutation for that set. Okay. And an example for this, let's see if there is an example. This, yeah, this one only. Uh, so the question says that k is equal to 1. The example says that k is equal to 1, and the set contains 2 and 3, right? So the difference between these elements is 1, that is less than or equal to k. So this set is not possible. Making a permutation using this set is not possible, right? So this was first case for which the given permutation is not possible. Now another case that we need to notice. Now here, we will use the point that we will do this thing for all of the eyes, right? So again, let's say we have the set, right? So for any si and si plus 1, for any two consecutive elements in the set, let's say si plus 1 minus si. Now let's say this thing is greater than 2k plus 1. Then what will happen? Okay, let's say this is si on the number line, right? This is si, this is si plus 1. Both of these elements exist in the set, right? Now there will be an element between these uh, sx, let's say, whose difference from si is greater than k. This thing is greater than k. This particular uh, this particular length L, let's say, is greater than k, and this particular length is also greater than k. So that's where 2k plus 1 came from, right? So if there exists any element between si and si plus 1, that is at least at that is more than three times more than k distance away from both of them. Okay. Then also we cannot form this particular set. Why? Why? Let's say we have inserted si already, and let's say we have inserted si plus 1 also already, right? So whenever Sx comes in the permutation, of course Sx will come in the permutation, right? Since Si is in the permutation, Si plus 1 in the permutation, and then permutation will contain Sx also. So the permutation that we were given, P1, P2, whatever, right? Whatever permutation we were given, uh, if Sx, if this Sx came after Si, then we will see that we needed to insert Sx in the set. Right. If it came after Si and Si plus 1 both, then also we can see that we needed to insert this Sx, right? Since no element is available within its range, right? Its range was K here and K here, but no element is available in this range. But we see that Sx is not available in the set. in the set given in the question, right? So that's why again we cannot form the desired set, the desired permutation for the set. Okay. So these were the two cases. The first case was SI, the two consecutive element difference between two consecutive elements should be less than equal to k and should be greater. And if it is greater than 2k plus 1, then we cannot right. So the implementation also for this question, let's see, we will take all the elements. Right. So I have just maintained the next and current. That's how I have implemented it. So if you can see if there exists an element, if an element exists in set, right? If an element exists in set, and the difference between it and its previous element is less than or equal to k, then we cannot form a set, right? CH stores if we can form a set or not. And also if any element does not exist in the set, and the difference from the previous element that exists in the set and the next element that exists in the set, if both of them are greater than k, then also we cannot form the set, right? So that's what the implementation looks like. Okay, I guess now let's move to the third question. Maybe bottom finally. Okay, so let's move to the third question. That is, yeah, for an array B, we define f of B as the second largest element of the array. Okay, the second largest element of the array. So, for example, this is the array, then 4 is its second largest element. Now we are given a permutation A of length n of n integers. It is a permutation we need to note also. Yeah. And each element from 1 to n occurs exactly once. Okay. We are given a permutation A of length n, and each element from 1 to n occurs exactly once. Now, what do we need to do? We need to compute the sum of s over all subarrays of A of size at least 2. Right. Formally compute the following thing. Okay, so I guess the question is simple. Still, let's first of all see what the question says. So we are given an array A. Let's say whatever the array is. Okay. What we need to do is we need to find the sum of the second largest element. Okay. We need to find the sum of second largest element over all of the subarrays of at least two size, of at least two lengths. Okay. Also, this is a permutation. Now the first thing we need to the first thing that we see is n is 2 into 10 raised to the power 5. So of course n square won't work. Out here. So yeah, we need to somehow calculate this sum in O of n or O of n log n type. Right? So what you can say is, let's say there is an element ai. Uh, this is the array A1, like, and there is some an. Okay. So let's say there is some element ai in the array. We will calculate for how many subarrays this ai will be the second largest element. Okay. We will calculate, somehow we will calculate for how many subarrays, for how many subarrays, number of subarrays for which this ai is the second largest element of that particular subarray. Okay. So now how can we calculate it? Okay. So the first thing that we need to notice, of course, if AI is the second largest subarray, if AI is sorry, if AI is the second largest element of the subarray, then one element greater than AI should exist in the subarray, right? One element greater than AI should exist in the subarray. Also, uh, no more element which is greater than AI should exist in subarray. Only one element that is greater than AI should exist in subarray. So for this particular AI, we will somehow we somehow need to find the elements that are greater than it in its left and in its right. So let's say these circles are elements greater than AI for now. Okay. These circles are elements that are greater than AI. Okay. So what we need to do is we need to take one element greater than AI in the subarray. So let's say we take this particular element in the subarray. Okay. So now how will our subarray look like? Our subarray should contain this element. Our subarray should contain AI, of course, right? And our subarray should not contain the other bigger elements. Okay. Other elements that are bigger than AI. Okay. We need AI to be the second largest element, right? We need AI to be the second largest element of the survey. So, to make sure, what we will do is we will take the AI. We will take one element greater than AI in the survey, and we will not take any other elements that are greater than AI in the survey. To make sure that only one element greater than AI, only and exactly one element greater than AI exists in the survey. Okay. So now let's say you took the element in the left that is greater than AI in the subarray. So now your subarray should start between these two elements. Your subarray should start between these two elements, and your subarray should end between these two elements. Right? For these two elements to exist in the subarray, right? Your subarray should start before this, and also your subarray should start after this, as you don't want this element to be in the subarray. Okay. So what you want is you want to start the subarray before this element, and you want to end the subarray after AI. Okay. You want to start the subarray before this element, end the element, end the subarray after the AI. Also, you cannot end the subarray after this element, as you don't want this element also to be the part of the subarray, as you want only one element that is greater than AI in the subarray. So, if somehow we know all the indices of the elements that are greater than AI, if somehow we can store all the indices of all the elements that are greater than AI in a set, let's say. Okay. So, and we know the index of AI. So, using the set, we can simply find the index of this element also, this element also, this element also, and this element also. Right. And that's what we need here, right? My laptop is a little low on. uh, Just a second. Okay. Here live, no? Yeah. Oh, so where were we? Yeah. So we will maintain a set that will contain all of the indices of the elements that are greater than AI. And we will see the indices of these four elements. Okay. These four elements. So using this, you can simply calculate all the subarrays. Okay. So what will be the subarrays? The first set of subarrays will be the subarray starting between these two elements and ending between AI and this element. Okay. And by the same logic, if you don't want to take the left element, you will take the right element in the subarray. And to do that also, let's say this is AI, this is this. Okay. So if you want to take this element in the subarray and AI also, of course, AI will be in the subarray. So where will our subarray start? Our subarray will start between these two elements, this element and AI. Our subarray will start between this, and our subarray will end between these two elements. Right? As we want to include this element in the subarray, and we don't want to include any other element that are greater than AI in the subarray. So that's the two sets of subarrays that will contain AI as their second largest element. That are the two sets of subarrays. This is the first one. This is the second one. These are the two sets of subarrays that will contain AI as its second largest element. So we will simply find the number of ways to start a subarray here and end a subarray here and multiply it by AI also, as we need to find the sum of the second largest element over all the subarrays. So can we do it using set? Yes, we can. Since the array A is a permutation, we will store the index. Since the array is a permutation, we will store the index of all AIs, right? We will store index of all AIs in, let's say, some B array. Okay, B1, B2, blah blah, B array. And we can simply, what we can do is we can iterate from the end of this array. So we will insert this index in our set, and of course, n n cannot be the second largest element in any subarray, as there is no element greater than n in a permutation. So there will be bn minus one also. So now for this bn minus one, what you can do is you can simply check these two things, right? We since we are iterating from the end, we have already stored all of the indices that are in the right of B1. That means all of the indices of the elements that are greater than this Bi minus 1. Or if you are at some Bi, since you are iterating from the end, you have already inserted all of the indices of the elements that are greater than I, right? All of the indices of the elements that are greater than I, you have already stored in the set. So using upper bound and lower bound, you can simply find these four indices and uh, then calculate the number of sets, calculate the number of subarrays for which AI is the second largest array. Okay, so let's see this its implementation also. Yeah. So uh, the array B is the input array and array is the index array. Okay, we will simply take input of BI and store the index of BI in A. Now we have a set S, right? And you will simply insert the boundaries of our array, that will be 0 and n plus 1. We have indices from 1 to n already in the array, right? So what we will do is for every I from 1 to n, you will check uh, IT and IT1 stores the upper bound, right? So I did IT minus minus. Uh, Now IT1 stores this element. Okay, this is IT1 and this is IT, right? So now to find the first set of subarrays, that is which starts between this and ends here, what the first thing you need to do is the first thing you need to check is this should not be a boundary of your array, right? There should be at least two elements before AI, right? So that's what we are checking first of all. If IT, that was the left element of X, X is the left element of uh, X is the left element of the AI, right? So if X is not equal to zero, if X is equal to zero, then it is a boundary, right? So the two elements before AI doesn't exist. So if X is not equal to zero, we will take another element in the left of AI, right? And we will simply calculate the number of sub-arrays. What are the number of sub-arrays? Y minus AI ways, right? Y minus AI ways are the ways of ending the sub-array, and X minus the star at IT is the number of ways of starting the sub-array, right? As you can see here, this is Y, this is X. So this is AI, this is Y, this is X, and this is another IT, and here we will go at IT1. Okay. So first set of subarrays will be X minus IT, uh, X minus IT, X minus IT ways of starting the subarray, and Y minus AI ways, and Y minus AI ways for ending the subarray. These are the number of subarrays for which AI is the second largest element. So since we need to find the sum of the second largest elements for all subarrays, we will multiply AI here, right? So that's what we are doing here. I I needs to be the second largest element. For I to be the second largest element, these are the number of ways of ending the subarray, and these are number of ways of starting the subarray in its slot. Okay. Simply same thing we will do for the right also. If y is not the boundary of the array, if y is not the boundary of the array, then we will take IT1 also in the further right and simply calculate the number of ways of ending, starting and ending the subarray in its right. And that's how we can calculate the sum of the second largest element of all subarrays of the given array. Okay, I guess it's clear to everyone, I hope. Let's move to the fourth question. Okay. So you are given two binary strings A and B, both of length n, right? And you can perform the following operation on A multiple times. Okay. Choose L and R such that choose L and R such that you can flip AL to AR all the bits between AL to AR, and the cost of this operation is one if AL and AR are equal, otherwise it's zero. Right. So flipping a value means changing it to one if it was zero and vice versa. Yeah. Yeah. So the question says question four and five also. Five is the same question. Uh, let's just do both of them simultaneously. So question four and question five are same. For question four, we need to output the minimum cost only, and question five, we need to out the valid set of subsequence also, set of operations also. Okay. So first of all, what is the question? Let's understand that. Okay. Yeah. So the question says you are given a binary array. Okay. You are given a binary array. Now, what operation you can do is you can choose some L, you can choose some R, and you can flip all the bits between L to R, right? Flipping the bit means if the bit is zero, then make it one. If the bit is one, then make it zero. So that's what flipping the bit. Like, yeah. So you need to select L and R, and we can flip the bit. And the cost of this operation is zero if AL is not equal to AR, and one if AL is equal to AR. And we need to minimize the cost. That means we need to minimize the number of these type of operations, right? So what is this? AL is not equal to AR means one end of the subarray should be zero and another end of the subarray should be one, or one here and zero here, right? So that's what we need to do. Okay. So first of all, what, how many possible ways are there, how in which we can perform this operation? Right. First, we need to do as much as possible using this operation only. We need to minimize this particular operation. Okay. So let's say there are some set of zeros. Okay. Then there are some set of ones. Yeah. When there are some set of ones, then there are again some set of zeros and so on. Right. And so on. And this is A initially, right? And you need to transform A to B. There will be some B given. You need to transform A to B, right? So the first of all, you can say that AL is not equal to AR. This operation we need to do, right? So what we can do is you can choose a consecutive 0 and 1. Of course, if all of the elements are 0 and all of the elements are 1, you cannot do. Otherwise, you can always do this, right? You will find at least one that is consecutive to a 0, right? So what we can do is you can choose this one, you can choose this 0, and uh, you can do the operation flipping bits on this particular subarray. What will this thing do? This will simply transfer the 1 here and 0 here. Again, if you do this operation in these two elements, for these two elements, again, they will just flip, right? So 1 is here, 0 is here now. So what are we doing effectively here, right? What are we doing effectively here? We are just moving the one. Okay. What does that mean? You can move any element of the array, right? Any element of the array anywhere, right? Let's say if you want to move this one to here. Let's say you want to move this one to here. What you can do is, first of all, you will transfer this one here, then this one here. Of course, when you transfer this one here, 0 will be here and 1 is here. Now you will transfer this one here, so these two will switch. Now these two will switch. So here it becomes 0 and here it becomes 1. Now you will bring this one to here by applying operation on two consecutive elements, right? So what does that mean? If if, if somehow you can make the counts, right? Uh, Clearly we can see that we can transfer any element anywhere in the array, right? If you want to transfer this one here, you can easily do that, right? Keeping the counts of the other elements and the position also of the other elements same, right? You can transfer the element, which is basically you can swap two adjacent elements, right? Effectively, you can swap two adjacent elements uh, easily, right? So now, if somehow you can make count of 0 and count of 1 in array A and array B equal, right? If what's happening here? Yeah, if somehow you can make count of zeros in array equal to count of zeros in array B, and this thing simultaneously implies that count of sorry A and 1 here. Count of ones in array A and count of ones in array B. Count of ones in array B. If somehow you can make these things equal, then you can transform array A to array B by swapping elements or by transferring the elements within array, right? We have seen it here, right? So now what we need to do is we need to somehow make the counts in array A and array B equal. Okay. So to make the count in array A and array B equal, first of all, let's say you have some x zeros, x zeros, and you have some y ones, okay, in the array. So let's say you have already transformed the array into all zeros first and then all ones after that. of course, you can transfer the elements. We have seen earlier that you can transfer the elements within the array. So you have transferred all the ones to the right side of the array and all the zeros to the left side of the array. Okay, you have already done that. Now, somehow you need to make the count equal. Okay, somehow you need to make the counts in array A and array B equal. Okay, now what you can do is, let's say zeros in A are less. Let's say you have, what you can see here is, let's say you have four zeros in A, but you need six zeros to make the count equal. Okay, so what you can do is, you can do the operation in this particular subarray, taking one zero and these two ones, right? For this operation also the cost is zero only, right? Zero and one are different. So after doing this, what will happen is, sorry, for four and six, you will take one more, right? You will take this. Yes. So what will happen after we perform an operation on this? This zero will become one. These three ones will become zeros. So our count of zero has gone to two now, right? Our count of zeros has gone to two. Has increased by two. Sorry, our count of zeros has increased by two. Initially, there were four zeros and some amount of ones. Now, what will be there? Zeros are three, then there is a one, then there are three zeros, then there are all the ones, right? So initially there were four zeros. Now we have got six zeros. That's what we needed, right? And if you can somehow make the count equal, then of course you can transform A into B. That's what we have seen earlier. So, in how many ways, in how many arrays can you make the counts equal? If let's say you cannot make the count equal, then you need to perform the second type of operation that takes one cost, right? If you somehow cannot do all of the operations during this, then you will need to do one operation of this, right? When will that happen? Let's say there are some zeros in A. You have already sorted the array already, right? Also, you can see that the the constraints on A are very less. So of course you can perform n square to sort, or yeah, and you need to output the sorting operations also, right? So you have already sorted the array. So you have, let's say, some x ones and some x zeros and some y ones. Okay, this is some x zeros. And here there are some y ones. Okay, that's what you need to do. Let's say you have all zeros in the array. Okay, in the array A, and there are some zeros and some ones in array B. Now you cannot transform A to B without performing the that operation, right? So you need to perform that operation on any one element. Let's say you do it here, and then you can of course transfer A into B. Yeah, for that you also need to see. First of all, let's say there are some x zeros and some y ones, and these are all non-zero, right? X is not equal to zero, and y is also not equal to zero. So how many different counts can we transform this into? Okay, let's say there are some x zeros and there are some y ones. Okay, so what you can do is you can simply take this whole subarray and apply a bit shift, apply a what uh, change the bits of all inside this subarray. So after performing this operation, our array will look like one, 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 and then zero, and then these two ones, right? And similarly, if you do operation on this particular subarray, then it will be three ones first, oh sorry, three zeros first, and then a one, and then all four zeros. What does that mean? If x is not equal to zero and y also is not equal to zero, then you can change x and y to any number, right? Given the fact that x is not equal to zero and y is not equal to zero, right? Y is not equal to zero. x is not equal to 0 and y is not equal to 0, you can change the count of a from anywhere from 1 comma minus 1, 1 comma n minus 1. What is 1 comma n minus 1? 1 comma n minus 1 means 1 0 and n minus 1 1. 2 n minus 1 comma 1, right? You can change the count within this array A to anywhere between these two, right? So when will you need to perform the second type of operation? It will only be needed when either x is equal to 0 or y equal to 0, or you can say x is equal to n or y equal to n, which means all of the array contains only zeros, right? If A contains only zeros or only ones, then you need to do this. Also, we have seen that if x and y both are not zero, uh, and you need to convert it to B. And if B contains all zeros or B contains all ones, let's say B contains all zeros and our array A contains, let's say, two zeros and three ones, or four ones, then also you cannot transform array A to array B. You cannot transform this without the second type of operation. Why? If you change, if you want to change the count of ones, you of course cannot make it zero, because if you apply this operation, then at least one will be left, right? If you apply any operation of L to R, where L is 0 and R is 1, or L is 1 and R is 0, then of course one will be there after the operation also. And this 0 will become 1, or this 0 will become 1 after the operation. So if B contains all zeros or all ones, and A is not equal to B right now, if B contains all zeros or all ones, and A is not equal to B, then you will need to perform one operation of second kind. Okay. And similarly, if A contains all zeros and or all ones, and B is something like 1 0 1 1 0 0 whatever, then also you need to do that operation once, right? Now you will do that operation, let's say, for this, and now you will get three ones and three zeros. After that, of course, you can shift the elements within array A using the first operation only to make the array B. So that's the solution for the first part of the problem, for the easy version of the problem, which is, let's say, the implementation also. This is the easy version, right? Yeah. Yeah. So for easy version, CT0 and CT1 are counts of zeros and ones in array A, and C0, C1 are counts of zeros and ones in array B. So, of course, if the counts of zeros and ones in A and B are already equal, then you do not need to perform the operation of the second kind. If either of the either A or B contains all zeros or all ones, then you need to perform the operation of the second kind. Otherwise, again, you do not need to perform the operation of the second kind. So that's the logic of the easy version of the problem. I hope it's clear to everyone. Now let's move to the second version, hard version. Here also it's the same thing, just you need to implement whatever I have said till now, right? What you will do is you will take where did we start? Yeah. You will take the array, you will take the array, you will sort the array, you will bring all the zeros to its left, all the ones to its right. How many operations will it require? For any one element, you will move it to at most n position, right? So n square operations may it will be sorted. And how many operations are we allowed here? N is 50, and 5,000 operations are allowed. And 50 ka square is 2500, right? Yeah. So n square operations are allowed. So it's not that big of an issue. So yeah. So n square operations, you will first of all sort the array. First of all, you will sort the array in n square operation. After doing n square operations, after sorting the array, of course, you will first of all check you need to perform the operation of the second kind or not. Yeah, that is a different case. Okay. So you will sort the array first of all, then you will see the counts. Okay. If the count of zero is less, you will make convert some ones into zeros. If the counts of zeros are more, you will convert some zeros to ones. So after converting or after making all of the counts same, after making count zero equal to c zero, what you need to do is you just need to shift the elements within the array, right? Let's actually look at the implementation through the code. It would be better. Okay. So, like earlier, we have stored the counts of zeros and ones in both the arrays. Our vector v stored all of the operations, right? So, let's say if b contains all zeros or b contains all ones, right? If b contains all zeros or b contains all ones, then what we need to do is first of all, let's say B contains all zeros and A also contains all zeros, or B contains all ones and A also contains all ones, then do not need to perform any operation, right? So that's this case. And if that's not the case, then we need to perform something, some operations, right? Again, what we will do is, since B contains all zeros or all ones, since B contains all zeros or all ones, what we will do is we will sort the array. Here you can see we have how will we sort the array? This is the implementation. This is there is some L. L is the element of the first one of the array. Okay, so that's what I have done here. L is the element of the first one, and for all of the elements, you will find any zero. If you find any zero, you will find the first one after it. You will find the one before it that needs to be replaced, and you can simply replace it. Let me show you how. Okay. So let's say there are some zeros already and there is some one. So my L stores the index of this one. Okay. So you will iterate after this. If you find, let's say, one, 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 the first time that you found zero, what you will do is you will transform this zero to here, transport this zero from here to here. How? Simply swapping adjacent elements that we have seen earlier. Yeah. So you will simply transfer this zero from here to here, then here, and then here. Right. That's what you will do. So after performing these four operations, your array will become something like this. Right. And now your RL will store the next one, the first one in the array. So that's how we are sorting the array. Okay. So for every element, if the element is one, you do not need to perform anything. And if it is a zero and it is before L, okay, it is before L means it is the starting set of zeros. So again, you do not need to perform any operation. But if it is a zero and it is after some ones, then what you need to do is you will transfer that zero in the beginning. So you will simply take a j from I and you will transfer it to L. And that means the array will be simply array will AI and AL will be swapped. Okay. That's what we are doing here. And after that, after performing this operation, you will need to update your L, right? You will need to find the next one. Okay. So that's how we are sorting the array. So what we have done till now is if B contains all zeros or all ones and A is same as B, then do not need to do anything, right? And if B contains all zeros and all ones and A is something like and A is not equal to B, then first of all we will sort the array. So after sorting, A contains some zeros, right, and some ones, and B is either all zeros and all ones. If B is all zeros, you will simply perform one operation here. If B is all ones, you will perform one operation here, right? So that's what we are doing. That's how I have implemented it. I have found an L and R, that is where the array A and B are distinct. Okay, and perform an operation at LR. And after that, output all of the operations. That's what this case is, right? And now let's say B does not contain all zero or all ones. That means B contains some zeros and some ones. And if in that case also, if A contains all zeros now, if A contains all zeros and B does not contain all zeros or all ones, you will need to convert at least one zero to one. For that, you will need to do one operation of the second line. So using this, I have converted the first element only of the array. If it was one, I have converted it to zero. If it was zero, I have converted it to one, whatever. Yeah. So that's what you need to do in this case, right? If A contains all zeros, but B does not, right? And in all of the other cases, you need zero cost, right? And now to implement it again, this is the same sorting algorithm used earlier. Sorting the array A. First of all, you will sort the array using the same logic. After sorting, what you need to do is you need to make the counts equal, right? After sorting, after you have already sorted the array, you need to make the counts equal. If zeros are less, you will take some ones and convert it to zeros. If zeros are more, you will take some zeros and convert it to ones. So that's what we are doing here. It is a simple math thing. Um, Everyone implements in their own way. So you can also try in your own way. Yeah. So if L, that is the number of zeros in the array, or you can simply say CT0. It's the same thing. If it is greater than C0, that means zeros are more in A. So we need to convert some zeros to ones. So that's what we have did here. That's what we have done here. And if zeros are less, then converting some ones to zeros. That's what we need to do. And after that, you simply need to transfer the elements. That is, if AI is BI, then you don't need to do anything, right? And let's say if AI is not BI, then what will we do? We will find the first element that is equal to BI after A, after I, and we will simply swap it. So what we do is, let's say array 0 1 0 0 0 1 1 as for something, and B is something like 0 1 1. Sorry, it is 1, right? So you will find that these two elements are different. है ना? यहाँ पे कुछ ना कुछ होगा. Now you need to bring a one here. You will find the first one after this index, that is this, right? And you will simply transfer this one to here, like this. Yeah, I shared this for the earlier. That's what we are doing. Like after again, let's just go through it again. First of all, uh, some edge cases you can say. If B contains all zeros or B contains all ones, then what we did is first of all we sorted the array A, and then we performed the required action, right? For the subarray that is not equal to B, we performed an operation on that, and that was the second type of operation where AI and AJ, so AL and AR are equal. So that's why cost is 1 year, right? Cost is 1 year. Otherwise, the cost was zero. And after that, we just outputted all the operations. Again, if A had all zeros or all ones, you first of all need to convert at least one zero to one, or at least one element to zero, right? So that A contains at least one and at least one zero. So that's what we did. So in this case also the cost of operations will be one, right? Otherwise the cost of operations will be zero. After that, we sorted the array so that all zeros are all ones are after all zeros, right? After that, you converted some ones to zeros or some zeros to ones based on the requirement, based on the required number, right? Using the counts. If zeros are more, you convert some zeros to ones. If ones are more, you convert some ones to zeros. That's what you do. So, and after that, what you do is uh, simply see all of the elements. If AI is equal to BI, then don't need to do anything. And if AI is not equal to BI, then simply find the first element that is equal to BI and transfer it here, right? From the right side. And also the count is same here. That's what we have done earlier. So this works. And yeah, that was the implementation. This question. I hope it's clear to everyone. And yeah,